a board member with Upper St. Clair Citizens for Land Stewardship. I work for Skelly and Loy in Morgantown, West Virginia, and we've designed some of the work in the township in regards to the McLaughlin Run project. I have 13 or 14 years of experience in natural resources work, and I'm a graduate student at West Virginia University in Morgantown studying wildlife and fisheries resources. Today we're going to talk about water everywhere and stream restoration activities. But before I start, I wanted to review some definitions. This will help us to understand the whole process a little bit later. The first term is fluvial geomorphology. The term has been coined by academians in regards to fluvial, meaning flowing water, geo, meaning sediments, soils, the geology of the area, and then morphology, which is in regards to the structure of the underlying rock and soils. Then a term that is quite often discussed in this type of work is bankfull. Bankfull is basically the area between the flowing stream at the point before it starts to flow out onto the flood plain. The flow of the water during normal year isn't at bankfull, but during a certain storm event, which usually is less than 2 years, every 2 years you have a bankfull event. And Luna Leopold, who is the son of, or was the son of Aldo Leopold, two great scientists that America had, basically indicated that bankfull stage corresponds to the discharge which performs channel maintenance. It maintains the form of the channel and is the most effective discharge at moving sediment, forming or removing bars, forming and changing bends and meanders, and generally doing the work that results in the average morphologic characteristics of the channels. That's a mouthful. Dave Rosgen, who's another practitioner in this area, his definition of bankfull is the incipient elevation on the stream bank where flooding begins. Thus, it's this point where you're above your average flow but below the floodplain. Another term we're going to discuss is terrace. The terrace is the abandoned floodplain. It's the previous floodplain, but due to throughout history, the stream channel entrenches, it evolves, and as it's evolving and moving down, you get terraces that form above it where it no longer floods at that elevation. And I've in the handouts listed a few websites you can go to in regards to learning more about these definitions. Okay, the planning process is a holistic process, and in McLaughlin Run, it actually started with the Lower Chartiers Creek River Conservation Plan that was performed a few years ago that included all of Allegheny County and parts of Washington County. And this study was a byproduct, a recommendation of that conservation plan. Then we put in for some grant monies and got the funds to complete the McLaughlin Run watershed assessment. One of the recommendations of that assessment, once we knew where problem areas were, was the three-hole golf course area in Upper St. Clair Township to do the engineering design for that restoration area. And then following that design effort, construction was completed. And this is just a photograph of that completed project area by the second hole of the three-hole golf course. Well, what are some of the characteristics of McLaughlin Run? Well, there's approximately 7.2 square miles, approximately 7.9 perennial stream miles. McLaughlin Run and Grazers Run are the two named streams. It's located in Bethel Park, Bridgeville, and Upper St. Clair. The land use, in no particular order, is residential, commercial, forest, and water resources. And that brings us to some of the reasons we're having problems in this watershed is approximately 21% of the surface area is impervious. That means during storm events, this water is getting into the streams very quickly. This becomes a problem because the water is not absorbed into the soil and thus into the groundwater. It just very quickly goes from hitting the roof of your house or the roads and goes right into storm sewers, which empty the water right into the streams. And that is one of the biggest problems McLaughlin Run is what it is today. Well, we had basically two methods we used when we did the assessment. One was the U.S. Department of Agricultural's Stream Visual Assessment Protocol, and then the Rosgen Stream Type Classification method. I'm not going to go into every one of the assessment elements, but these are the 15 elements: channel condition, riparian zone, bank stability, barriers to fish movement. Anything that's a few feet above the water is going to be difficult for pretty much any fish in McLaughlin Run to try and jump. The fish that are in McLaughlin Run are not like salmon of Alaska that can jump 3-4 feet, maybe more. These fish, if they're jumping a few inches, 6 inches, that's a huge jump for them. So if there's a pipe coming out from one location to another and it's higher than this, there's a barrier to those fish moving from one place to another. Canopy cover. The better the canopy cover, the better the habitat for fish and other organisms. Okay, the Rosgen Stream Type Classification has 7 major types, A through G, and they look at things such as slope, sinuosity of the stream in the area, what's called width-depth ratio. On our cross-section we have over here, basically that's the width from bankful to bankful on each side of the channel to the average depth, not the maximum depth, but the average depth. And then there's a chart with different numbers that you compare that width-depth ratio to gain an understanding of what type of channel you have, and entrenchment ratio. To ascertain this, we review that bankful. And this is the chart we look at. There's 2 different types of stream channels. We have single thread channels, which are pretty much all we see in McLaughlin Run, and then we have multiple channel streams. These are streams that have gone so choked with sediment that they basically leave one channel and form multiple channels. These you see quite often in deltas, like down in the Louisiana area. Then in single thread channels, you look at, again, your entrenchment ratio, your width-depth ratio, your sinuosity, and your good streams are basically your A's, B's, and C's, and E's. And your troublesome channels are your G's, F's, and D's. And as you're looking at the stream, you determine whether it's a dominance of bedrock or cobble or boulders, gravel, sand, clays, and then that helps you to determine whether you have an A2 stream or a G2 stream or what have you. As a part of the assessment, we went to the gauge stations on neighboring watersheds. Chartiers Creek, it was down in the Carnegie area, and we did cross sections there and compared it to the gauge height and determined the bankful discharge and came up with a reoccurrence interval. And I discussed earlier that typically that reoccurrence interval at bankful is below 2 years, but for the most part it's closer to 1. And Chartiers Creek, it's every 1.2 years, Buffalo Creek 1.7, and so on and so forth. And this can help you to understand how often your stream will hit that bankful elevation. In the case of Chartiers Creek and its tributaries, it's generally every 1.2 years you're going to have a flood or close to flood event. When does a stream need restored? The D's, the F's, and the G stream types. The stream you see here, this is right by the post office by Lesnett Road. That's the bridge at Lesnett Road. And as you can see from this, there's a lot of problems here. You have no vegetation. There's bank erosion taking place there. The sod of the grass is being undercut. This tree, if you've driven down Lesnett Road, you may have looked over on your right. Its roots are being undercut, and it's not too far from being toppling over into the stream. You can also see a lot of sediments along the edge of the stream, some concrete. This is material that's been moved from upstream locations and is being deposited here as the storm events subside. That is not a good condition to be in. The stream is entrenching. The stream at bankful probably is here to a point over here, but since there's no floodplain in this area, the stream is cutting down to try and hold that capacity of all the water flowing during storm events, because McLaughlin Run now carries more water in it than it had evolved to carry before man came. Let's move on. Issues for McLaughlin Run watershed. It's an urban landscape. We have sewer lines, gas lines, bridges and roads, and recreational facilities that we have to pay attention to. We have high amounts of impervious areas discussed before. Really, though there are areas of forest land, they're not large in comparison to the amount of impervious area. Those would be the residential and commercial areas. Previously culverted and channelized stream links. This is very important because the water is still getting into the channel, but you no longer have the areas where the stream can flood because they've been channelized. These channelized and culverted areas, as the water is shooting through there, the water is gaining in velocity, it's carrying more sediment, and thus is more erosive to the stream banks around it. So the stream down cuts to try and maintain all that water it's carrying. The lack of riparian corridors and flood-prone area. It's essentially the same thing as a stream running through a culvert or a channelized area. If you don't have any flood-prone area, you have no place for the stream to slow the effects of all the stormwater it's carrying. It has no place to drop its sediments it's carrying. And of course, we have development to the edge of the stream. No buffers. That just exacerbates everything. Well, after we assessed the stream, we came up with the #1 priority, which was the 3-hole golf course area. This is where you're coming down from the second tee to cross the bridge to the second green. And this is where our staff was surveying the stream. And you can see in this area, here's the riprap gabions, and you can also see the stream bank here has virtually no vegetation on it because the velocities of the stream during a bankful event are so fast that the vegetation's been stripped away. It just can't hold on. Well, there's a number of restoration techniques that can be used. Of course, the traditional engineering type, trapezoidal channels, riprap, gabions, things like that. Natural channel design, stream channel design, these include best management practices, native plantings. And then there's the Roskin approach, which sort of includes all of those, but also includes things such as rock veins, cross rock veins, J-hook veins. These structures help to maintain the water flowing through the center of the channel, thus keeping the erosive force of the water from eroding the stream banks further. In a lot of these stream restoration projects, you actually use all of these techniques because, especially in urban areas, one approach isn't necessarily going to correct all the problems you have. So in this case, we pretty much use all of them. McLaughlin Run, in one sense, is the community sewer or drainage ditch. There's non-point source pollution that is coming from all sorts of places throughout the whole watershed, whether they're pipes coming from parking lots into the stream, whether it's pollution coming from the golf course itself, fertilizers, maybe pesticides, whether it's sanitary overflow and the waste products coming from there. Also, the project area was aesthetically unpleasing with the gabions and limited riparian corridor. The riparian corridor is the vegetative corridor, and there's many places through McLaughlin Run where there's nothing but grass, maybe some asphalt. These projects try to get more of a riparian corridor formed so that it forms a buffer to catch some of the non-point source pollution that's being put in. Then the three-hole course was selected to be engineered, and we used a number of best management practices, new channel or reconstruction. We graded back the stream banks to allow more of a flood-prone area to be located throughout the area, throughout the project area. When we did that, we did bank stabilization techniques, which included planting native vegetation and even some non-native vegetation, such as ryegrass and crown vetch, just to stabilize the area quickly until the natives can get established. Then sometimes you need to use debris jam removal, best management practice, to take away a rock or concrete or some other structure that is causing water to erode a bank or whatnot. We revegetated the area. We included rock veins to transport the natural bed load of the stream more efficiently. And then we also used some traditional engineering techniques in the form of some wire mesh called Terra mesh, which helps to, you use soil instead of rock, and you plant these structures with live stakes so that they help to reinforce the Terra mesh in place, and then in time the steel structure of the Terra mesh just erodes away, dissolves away, and then you just have a vegetated bank. And then of course road maintenance can be a part of it too, and there's a number of places where McLaughlin Run Road is directly adjacent to McLaughlin Run the stream, and certain road maintenance activities need to be done to limit pollution and physical impacts to the stream. Well, what are the costs and benefits? And yes, there are benefits. There's a lot of benefits, and if there weren't benefits to this project for the community, to the township, I wouldn't be here speaking to you. A few years ago, Upper St. Clair Citizens for Land Stewardship and the township got together to discuss the opportunity. The township needed to understand how this project would benefit the community and what the costs would be. And we submitted an initial grant and received $102,000 to start the assessment and restoration process. CLS and the township provided time and material resources to prepare the grants. The staff, township staff and CLS had staff time and in-kind matches such as equipment, administrative time. Contributions from others included transportation of raw materials, volunteer time, and other expertise. Benefits quantifiable. To date, CLS and the township have been able to bring in $403,000 to move the project through all its different phases. We've reduced stream bank erosion and sedimentation. That may not seem much to folks, but the township used to, in the three-hole golf course area, used to have to dredge annually the stream due to it being choked up with sediment, which caused problems for the golf course area, the tennis courts, and some of the bridges downstream. Since these projects have been built, the township hasn't had to go in at all to do any dredging. The projects have helped to maintain the natural stream bed load, the natural sediment load that comes through, and it's reduced the amount of sediment that is being put into the stream. It's reduced downstream flooding. Walter Jarash had told us how folks from the tennis courts to the golf course and possibly the township commissioners have noticed the positive benefits that this project has had. When there's no flooding that occurs, there's no cleanup that the township employees have to go and do to improve and clean up these sites after this event has taken place. That means the township can put those funds to other places in the township or possibly save money over the course of the year. This project has also improved protection to infrastructure. The downstream roads, the downstream bridges are maintained by the township and PennDOT. The golf course, the tennis courts, as discussed once again, they're protected better because of these projects. These projects, when you have more flood-prone area, it can help to reduce the storm events because more flood storage is built into the floodplain. When you remove the floodplain, that flood storage isn't there, so the flood event can be higher. And of course, the thing that is near and dear to our heart at CLS is improved water quality and aquatic resources. We're going to have higher quality fish abundance and bugs in the stream. Other benefits, but these aren't really so quantifiable, include the 2001 Governor's Award for Watershed Stewardship. The township and CLS for this project was recognized throughout the state for its excellence. This is something that puts our project on the map. Improved riparian corridor aesthetics. The area, as time goes by, is going to look prettier and prettier. We already have more fish, more birds that are living in the area that weren't living there before. Improved environmental education, adult and youth education. I'm here today providing adult education in regards to the QUEST program. The school district also has their high school students coming down doing water quality sampling for macroinvertebrates and fish. And then there's community cohesion. People have noticed the positive impacts that have occurred due to the project. The different phases. We've had 4 phases or have 4 phases. Phase 1 was an EPA grant, and that did the assessment and design. Phase 2 was for the construction of the 3-hole golf course area. Then we have Phase 3, which is also part of the 3-hole golf course area, but that's for construction this fall. And then we have Phase 4, which is the design of an area that is pretty much up on the Bethel Park, Upper St. Clair border. And other things that are ongoing is the Citizens Volunteer Monitoring Program that Jan Fleckenstein has been running, and her session will be the next session to be discussed next weekend. This is a list of the plants that were used. It's not a complete list, but it's a good list. American sycamore, red bud, 2 different types of dogwoods, red maple, black-eyed Susan, wing stem, New York ironweed, Joe Pye weed. These are all natives except for 2 that were used to just stabilize the project area in the short term. And then the project monitoring. How do we evaluate the project area? Well, restoration was defined by the National Research Council as the return of an ecosystem to a close approximation of its condition prior to disturbance. We're not trying to return McLaughlin Run to a pristine situation. We don't have a pristine surface area, the land area, with all the imperviousness, so it will be impossible to try and get it back to its original pristine condition. We're just trying to get McLaughlin Run to be stable, to not be eroding, and to green the area up so that we get improved aesthetics, improved wildlife and fisheries habitat, and just to make the area much more attractive in any way you can think. Then long-term monitoring is something that this picture shows. It shows CLS and our volunteers getting out and taking a cross-section of the stream. And what this cross-section allows you to do is to see, is the stream continuing to downcut, or is the stream depositing sediment? In this case, after construction was completed, so far we found that at least at this cross-section, actually at both cross-sections we are in fact getting sediment to be deposited in the project area, which means that sediment isn't flowing downstream and causing problems in other sections of Upper St. Clair and or Bridgeville from the project area. And so, but we're not just sampling for the physical constraints, we're also sampling the macroinvertebrates, the biological side, and we're also sampling water chemistry to look at water quality parameters in as many different ways we can. And finally, I just wanted to add this slide in. What has Upper St. Clair and CLS built? It's a lot more than just a pretty and healthier stream. See the stream entrenching very well. McLaughlin Run never was straight like this when years ago, 30, 40 years ago, whenever it was, McLaughlin Run was pushed over to this point, and if you look down the stream, it has no flood-prone area, no floodplain. But you can see Bankful, and Bankful is basically this first lip you have right here coming up where the grass starts to plane out. That's about where Bankful is. And then in this tributary coming in, you can see how far McLaughlin Run has downcut, because this tributary should be at the same grade as McLaughlin Run itself, but because it's probably an intermittent channel, it doesn't have enough flow going through it all the time to stay at grade, and then this tributary's had to cut through this bedrock, which it doesn't have the stream power to cut through, where McLaughlin Run is just downcut tremendously, and you now actually have a waterfall situation, which probably was not an original situation. That has just formed to try and maintain that. And even on that tributary, you can see how it's very steep on each side, and that's probably because of the golf course up top just water getting into it so quickly, it just doesn't have it's not fortified enough to handle it, so it's down cutting itself. Yep. Again, you can see McLaughlin Run here, how it has no floodplain. It just has the gabions on each side, and during a flood event, that water fills that whole channel, and if it's a really bad event, it will eventually come out here, but it can be really damaging at that point, and you can see how it's had to be armored to be able to maintain this area. And here's our first project area, or the first part of the project area. And before we did this project, you had an unvegetated slope that was very steep, and it was eroding tremendously. Well, part of the design, we cut back the bank so it was more like a 2-to-1 or 3-to-1 slope, which allowed the vegetation that we planted to colonize and stabilize and help to protect the area. And if you look here, the stream's trying to regain its sinuosity, which helps to drop off the energy it's carrying. And you see on the left side some gravel and cobble and other material in there. And then a little further down you have another bit of cobble on the right side and sediments. Well, those are point bars that are forming, and you always find those on the inside meander of a stream. And so the stream, because you have the flood-prone area over here to slow down the stream during a flood event, it's regaining its natural sinuosity. And that's a good thing. That's sediment that's, to some extent, staying in this area and not causing problems downstream. Project area, we were just asked about the native vegetation in the project area, and the vegetation with the red stems is red osier dogwood, and then some of the vegetation with more of a darker olive drab brown color, that's the silky dogwood, and both those are native species to the area, and matter of fact, some of them were taken from up on the hill behind us, and when we stuck them in, they were about 18 inches long, and most of that was stuck in the ground. Now some of them are 3-4 feet long and have multiple stems coming off. This is also area black-eyed Susan stuck in here, and other vegetation that's moved in naturally on its own that wasn't planted here. This is also one of the areas where we did a cross-section and have been able to show how the project area is preventing sediment from moving downstream. And of course, pollution is attached to sediment. So when you have sediment dropping out here, you have pollution, like salt from the roads in winter, or maybe fertilizers or pesticides that are being used by residences and others that is deposited here. So this is a sink for storing those kinds of pollutants, and instead of going downstream and causing problems, they're stored here and will just dissipate and become a part of the earth again. Okay, here we are at the next portion of the project area, and this is right below the second tee where you cross the bridge to go to the second hole green. And the structure you're looking at in front of us is called a crossrock vein, and the part of the crossrock vein in the middle of the stream is a low point, and so gravity pulls water to that point throughout the year. And so as the rock vein's legs go out onto the left and right bank, they go up in slope. So during high flow events like flood events, the water has to move uphill there and thus is turned back to the center of the channel. What that does is, if you look on the left side and right side of the stream, you can see where soil has deposited and sediments. Well, that slows the water down, so the water drops its sediment load at that location. If you look the whole way along there, downstream you hit 2 or 3 rock veins in a row, and you can see the sediment has deposited along the gabions there. That's important because before we started this project, those gabions were being undercut and were about to topple over. Thus, this project has provided a benefit to the township by extending the life of these gabions for who knows how long. Also, on the downstream side of the cross rock vein is a pool. And within 15 minutes after this rock vein was installed, the contractor who was operating the machinery said that the fish were just schooling in that area, and just it's the place the fish want to be. There's depth, so they have protection from predators. There's a lot of oxygen there because of the riffle effect. That's where the food is brought to, because the water is being pulled there by gravity. So any food, whether it's bugs or other fish or what have you, that just flows through that pool. So that's where the fish want to be. There's everything they need to live. Then if you look on the right bank, you'll see some trees. Well, we cut the bank down there to give more of a flood-prone area, which has allowed that area to be vegetated a lot more. And every year, the density of the vegetation in that area will just get a little thicker and a little thicker, which will help to knock out more sediment, will help to beautify the area by making it more green and more of a buffer, a riparian corridor. And on the left side, we planted some red maples and maybe a few other species in there. Now on the right side, we planted red buds. As these trees get larger and larger, they'll provide a lot more shade, a lot more connectivity. The water temperature in the stream here will cool down dramatically in this area as the trees get larger, thus allowing less tolerant fish species to live in this area. In this area, only tolerant fish species that can live in water temperatures that get to be whatever temperature it is in this area, maybe say 70 degrees or so, which is pretty warm, maybe 75 degrees, can live in this area. Whereas a trout would want it to be 55, 60, maybe 65 degrees. It doesn't get that cold except during winter here, but this isn't a cold water fishery anyway, so it's not really a stream made for trout, but it's a warm water fishery, so we're talking more the kind of game fish you could find in this stream would be suckers, would be smallmouth bass, fish like that. We don't really have those kinds of fish right now, but they're fish that maybe in a few years we could expect to have put back in and people could actually fish for. Well, now we're looking at things from inside the stream channel, and we just were up at the bridge coming down by a cross rock vein. Then the water flows from the center of the channel to the tip of the first rock vein. The water deflects off that and flows off the tip of the second rock vein, and so on and so forth as it's moving around the meander. This keeps the water during all flow events being mainly in the center of the channel, which keeps the erosive force away from the outer bend of the stream, where we're trying to protect the gabions. Then we have where our camera operator is standing is in the flood-prone area. And this area from about where my hand is over to this point, this is the Bankfull elevation. So this is the channel forming flow, about maybe 18 inches high or so off the stream bed. And anything that flows above this is a flood event. And so we are now starting to get sediments that are depositing out in here, and this area increases the amount of flood storage during flood events, so it helps to prevent floods, destructive floods downstream at the tennis courts, other portions of the golf course, all the way downstream even into Bridgeville. This area helps to protect. Well, this is pretty much the end of our project and the presentation. The next section to be constructed is just downstream of this portion where you cross McLaughlin Run to hit the third green. We look forward to having folks come down and investigate this project area, and also to keep your eye open for construction and see how that area progresses. It should be quite an interesting project, and we'd like to thank you for your participation and watching the show.